Okay, in this video we're going to start to talk about logarithm equations or logarithmic equations, and we're going to start with the easiest case, which is when we have a logarithm equals a logarithm. So we've talked about before that exponentials and logarithms kind of cancel each other out, and so if I wanted to solve this, one way to do it to cancel out a logarithm would be to use the corresponding exponential. So this one that I've written down is ln, and that means the log is base e. And so to get rid of a logarithm, I would use an exponential, and I would have to also use base e. So why don't I use an exponential base e on both sides? So this is kind of like the opposite of, raising both sides to a power. Instead, I'm having the two sides be the power, and I'm inserting a base on both sides. Again, it turns out this is a thing that we're allowed to do. We're allowed to take a log of both sides. We're allowed to square both sides. We're also allowed to take the same base on both sides. And the idea is if this number is equal to this number, then e to the first power is the same as e to the second power. Okay, the reason that this is important, though, is if we have an exponential and a logarithm and they have the same base, both base e, then they should cancel each other out. And so we should just get back the thing that's inside the parentheses. Okay, let's take a step back though. There's actually an easier way we can think about this. If we have log of one number is equal to log of another number, we could have just gone straight from here to here by saying, well, the only way for log of x plus 2 to be the same as log of 37 is if x plus 2 is actually 37. So theoretically, we could have jumped this middle step. I'm just trying to show you why exactly is this true, and it's because we can use an exponential on both sides. Now we have a much simpler equation. We just have to solve this much simpler equation. 2 is being added to x, so we use its opposite, which is subtraction. So in 37 minus 2 would be 35, and so that would be our answer. Okay, let's try another one. Solve log of x plus log of x plus 1 equals log of 12. Okay, right off the bat, we're a little bit scared of this, just a little bit, not too scared, just a little bit. We have a log plus log. So we have to go back to video 1 in this section, which is saying before you do anything else, you want to combine multiple logs. This is the first time we've seen a log equation. This is the first time it mattered. When we see a log plus a log, our rule says you can combine them. You just have to multiply their insides. So if I use one of our laws of logarithms, it says that you multiply the two insides of the logarithmic functions. So now we have log of something is equal to log of something. They're both base 10 logs, log, or common logarithms. So that means the two insides have to be the same. And so if you wanted to, you could skip the middle step. I think I'm going to write it. I'm going to use an exponential base 10 on both sides. So we have 10 to the power log, 10 to the power log, which should cancel and give me x times x plus 1 is equal to 12. Okay, now this is an equation we have to solve. It's not a logarithmic or exponential equation anymore, so we have to rack our brains with how we would solve this before this section. And I see an x times an x. That means this is probably a quadratic, so let's rewrite in our standard way for quadratic. So distribute the x. X times x is x squared, x times 1 is x. And then we want everything on the same side, so subtract 12. X squared plus x minus 12 is equal to 0. And we can either use quadratic formula or we can factor. I think I'm going to factor. So x plus 4 and x minus 3 equals 0. And let's see, that means either x plus 4 is equal to 0 or x minus 3 is equal to 0. If we add 3, we get x is equal to 3. If we subtract 4, we get x is equal to negative 4. Okay, looks wonderful. Let's check our answer. We haven't been doing this a lot, but let's check our answer. So I'm going to plug 3 into this, and see if I get the same answer on both sides. So I'm going to just type it in a calculator so you guys can watch in the calculator. Back. Okay, so the original expression was log of x plus log x plus 1. And I'm going to stick in the 3. So log of 3 plus log of 3 plus 1. So random number. I'm also going to take the right-hand side, which was log of 12, and I get the same answer. So wonderful. X equals 3 is working out. Now let's try the same thing with negative 4. So I'm just going to scroll up and type the same thing. And let's see, second insert a negative, and then make that 3 into a 4. And then second insert, make that a negative, and turn the 3 into a 4. That doesn't look real good. Non-real answers. Okay, non-real answers. Some kind of error. So I think we maybe have an idea of what's going on here. We're not allowed to take a square root of a negative, and we had a similar rule that says you're not allowed to take a log of a negative. So anytime you see a negative in your answer, you should be a little suspicious. Also, anytime our equation starts off as having a log, we should probably check our answer, because this is always going to be a possibility that an answer would end up making it be a log of a negative, which we can't do. So let's just write down an explanation here. And the reason is log of a negative is undefined. So this solution, we've talked about solutions like this way back when. It's called an extraneous solution. It's a solution that kind of just pops up from the way we solve the problem, but it doesn't actually satisfy the original equation. So it's like a fake solution. So we only get one answer. And again, the moral of this whole video is going to be when you start with a log equation, make sure you're checking your answers.